here I'm saying if we know A and B are independent, then these equalities do occur. I want to say the converse of that is also true. In other words, if we somehow knew these equalities were all true, they all held, then A and B are independent. I want to say that, but I want to look into that first. Be careful. I know what I wrote here is correct, though. And I'm positive. Okay. All right. Here's an example. This is actually one we did before, but basically I'm going to state what we found using conditional probability. All right. So we have that bag of marbles, right? There are 10 red, 5 blue, and 8 black marbles, okay? And again, you can't tell the difference between the marbles except for their color. We're choosing marbles at random. Excuse me, we're choosing a marble at random. Then, okay, we choose a second marble at random. We don't put the first marble back. We don't do that, okay? We do not do that, as you can see. So we're going to find the probability the second marble chosen is red. We're going to do that for fun, using conditional probability. Okay. Actually, wait. Oh, wait. I need to take my notes. Okay, we're not going to do. Well. Oh, okay. We're going to find some conditional probability. That's what we're going to do. Let me just fix that. What we're going to do is this. Okay. We're going to find some conditional probability. There we go. So we're going to let A be the event. The first marble is red. We're going to let B be the event. The second marble is red. Okay? And basically what we're going to do here is we're going to find the probability of B given A and the probability of B given the complement of A. That's what we're going to do. Okay? Now, well, the first one, the probability of A, that's pretty easy, right? You're choosing a marble at random. There's 10 red marbles, okay? And there's 23 marbles altogether. So the probability of A is 10 out of 23. Now notice that since we're not putting the marble back, B and A are not independent, they're dependent. So in other words, what we have is the probability of B given A, okay? That's what we're looking for now. That's going to be 9 over 22. If A occurs, right, meaning we chose, the first marble we chose, we picked out that is red. Okay, so that means there's one less red marble in here. So there's 9 red and there's 22 marbles altogether. Well, now the probability of picking red, for the second marble would be 9 out of 22. Okay. But what if A did not occur? Well, if A did not occur, then the probability, okay, of choosing a second marble as red, if A did not occur, then the marble chosen was not red. So there's 10 red, but there's one less marble altogether. So we have 10 over 22. That's what we get. Okay, so that's what we get there. Okay, good. So that's what we get for the probability of B given A and the probability of B given A does not occur. Okay? I'll fix these slides later, but here, like, for some reason I wrote find the probability of B, but I should have written find the probability of B given A and the probability that B given A does not occur. Anyway, I'm just really basically writing out what we said last time, just in terms of conditional probability. That's all I'm doing. Okay. Anyway. Okay, so now here, this is actually how we can determine the probability that two events occur that are not independent. You know, we already saw that if two events are independent, you can easily find the probability they both occur at the same time. You just multiply their probabilities. But if they're dependent, then that's not so obvious. What you have to do instead is use this formula if you want the probability they both occur. So the probability then that both A and B occur, okay? If they're not independent, they're dependent, that's equal to the probability of A times the probability of B given A. That's the probability of B given A. That's what we have there. So what you have to do is you have to find some conditional probability in this case. Now let's go back to that bag of marbles here. Okay. So again, we have that same example here, okay? Now we're going to find the probability that both A and B occur in this case. That's what should be here. So we're going to find the probability here that both marbles, excuse me, that the first and second marble are red. That's what we're going to find here, okay? All right. So we have to get the probability of A, okay? So again, let A be the event the first marble is red. B is the event the second marble is red. Okay? Okay, so what we want is the probability then that both A and B occur. Because we want the probability that both marbles chosen are red. So what we get is the probability of A, okay? Right, that's the first one. We have to get that. That's 10 over 23. You know, we saw that already. Okay, so again, we're basically using this formula where A is the event, the first marble is red, B is the event, the second marble is red. That's what we're using here. All right. So what's the probability of B given A? Well, if A did occur, meaning the first marble chosen was red, what's the probability the second marble is red? There's one less red marble in this bag. So the probability would be 9 out of 22. 9 out of 22. Now, so what's the probability of both A and B occurring? It's this product, okay, which is 10 out of 23 times 9 out of 22, which turns out to be this. So again, we're just multiplying them together. We're just multiplying them. That's all we're doing. Okay, so that's what we do here, okay? All right, that's one example. The next one, I want everyone to try out, you know, now. Here you have a deck of 52 cards, okay? What you're going to do is you're going to choose a card. You know, you're going to choose 2 cards at random. The first card, though, you choose, then you choose the second one. In other words, you're not putting back the first card into the deck. These probabilities I want everyone to find. It'll take about 5 minutes, so let me just pause the recording. Okay.